prototyping an open source prosthetic sensor. Hi, my name's Turfta. I created Open Muscle, which is an attempt at creating an open source prosthetic sensor. This is a very small use case for someone that is missing a hand that has an intact forearm.
Now today is an exciting day for a couple of reasons. Take a look at this. This is the new dev kit board. Simplistic, it's thin, quite a bit thinner than the other one. Perfect, it fits right in the first time. That's super cool. So here is one of the feet being attached, and these are by Gatoron. These are Hall effect sensor keyboard switches, and this is going to be the basis for our bracelet. So there are going to be multiple cells. Each one of these is a cell, and it'll go around the forearm, and each of them will have a microcontroller attached. And in this case, I'm using another dev board because you can get these devices for about $2 USD, the microcontroller, the ESP32 C3 dev board, and the super mini variant. Then I have this LDO to change the battery voltage, which varies in between 4.2 volts and 3.7 volts, and this will produce a stable 3.3 volt output for us. So this LDO will pretty much do all we need. There is a built-in LDO that turns 5 volts down, but I just wanted to put this together. So that's our one component piece for the battery. The batteries are going to have to be charged in a separate device. We also have mounting brackets for the ESP32 C3, and then the 2 Hall effect sensors. And then we have some pins that we can use for other reasons, but just in case we wanted to, it is there for us. And let me just double check that, yeah, so that's ground. And let me make sure that these are, actually I don't even know if they're oriented correctly.
So it was at this moment in the recording of this that I realized I had messed up and mirrored the footprint of the Super Mini ESP32. Instead of the right column of headers, I had it on the left side. So this caused quite a bit of a problem. I was looking and tracing the ground 3v3, and it just looked anomalous. I couldn't figure out why it didn't look like it was traced properly. Yeah, and so that was an oversight. Again, this is why the prototype boards are nice. There's so many parameters. So being able to quickly and rapidly prototype, it also, you can make mistakes too. So I get excited, I'm only one person. I don't have anyone else double checking my work other than me. And sometimes I do make mistakes, but each mistake that I make, it does cost me some money and some time, and it kind of incentivizes me to be more rigorous and more detail oriented when it comes to the actual laying out of the schematic. And it would be nice if I had some other people look over the designs, but let's get back to the video, just letting you know what was going through my head at the time.
VCC, ground, and out. So these are actually facing the wrong direction. I have this facing the wrong direction, which is fine. And again, these traces are just for the test PCB, so that should be good. So they're going to be laying backwards, which is okay. And I'm also going to try for the first time to surface mount solder these ESP32 C3s. Let's see how that goes. Put these pads a little further away than I did on most of my other designs. I had a habit of putting them super close to one another, which was just a pain in the butt to solder. So delicate. But I learned my lesson, hopefully. Awesome sauce. And we're going to actually use these pins to hold in the ESP32 C3 because I can surface mount it. Okay. So I'm going to set the C3 on there like so. And I slightly apologize for not being a good camera tech, but the visual takes a back seat to the work. So what I'm doing is I'm just sticking the ends, the clippings of this through the holes to align this up a bit. I'm going to do it on all four sides. And this should get me enough stability to solder the whole thing. And you'll see what I'm talking about once we get under the microscope. So these pins here, I kind of made myself in KiCad. So I just wanted to line these up roughly. I was hoping that I wouldn't have to use pins at all and I can just solder this. But this is an experiment, so we'll see. Probably should have made the pins quite a bit bigger. And this is probably a bad idea. Trying also not to heat up the hall sensor while I'm at it. Gotta fire the camera guy. No, this is actually working surprisingly well. The other side might be slightly off because one side's a little easier to do this. Let's see how far off it is. And not too bad. So if these pads didn't work, I could have just used the through holes, but didn't make them big enough for header pins. Because I knew, well, let's say it's a happy accident. I believed I wasn't going to use header pins in this the whole time because header pins are a little bit finicky. They're also pretty big. Let's look at this. These connections are looking pretty good. Should actually be equidistant, so still in focus. Good. Yeah, so this board is looking kind of nice right now. Let's do the in focus shot of most of the board. Cool. So yes, we have the 2 hall sensors, and now we can apply our, and I do believe I got this one right. And I just realized a fatal flaw. I might have flipped this upside down. I'm pretty sure I did. But the nice thing, other than ruining this specific ESP32, is that everything should be exactly the same if I flip it up on the other side. And it looks like I did that. So yeah, so these pins should be on the other side, but they're mirrored, right? So if I flip this over, it's gonna be the same. So if I solder it on this side, it's gonna be the wrong way, like I just did. So this is completely wrong. Even though there's the shape of the ESP on there, you can't solder it there because, but if you flip it, if you solder it on the other side, then technically it is correct. I'm gonna bend these a little bit. Okay. Well, you know, we had one setback soldering on the correct side, but the designer had a flaw. So this hopefully will work. I'm going to get the LDO a little bit bigger. Oh, I didn't even record that. I don't even know if this will work when I plug it in. If the light will even come on. So I'm gonna hold this because there's metal on the bottom of this board, and I don't want the pins to hit it. Well, look at that. Plugs it right in. Battery is as big as the board, and it's working. So here is a functional little mini unit. It's kind of cute. And let's disconnect the battery. Now let's put on the feet. So feet should just pressure in there, which is nice. It's kind of like an audible snap. There's even this little hole cut out for it's just kind of cool how that all worked out. Sits flush. Awesome. There we go. This is one of our little units. It's kind of neat, pretty slim. Gonna put some feet on it. We're gonna coat it, and this is exciting. It powered on. We can see what we can do from here, I need to print the case for it. That's why it has these 4 things. So I'm gonna go ahead and print the case off. And I'm not sure, but yeah, this is a good day. So just so you can see the size of the battery, I'm using the 500 milliamp hour battery. This is gonna pull 100 milliamps when it's running and sending packets. So this will allow it to run for 5 hours for each one. There's no charging circuit on this yet. I will work on that, but I was trying to use as minimal components as possible just for a prototype. I can always charge these by hand later. Of course, I'll try to make it easier for myself, but I already made a couple mistakes, but we were able to navigate those mistakes. We're able to flip the board, thankfully, and yeah, it works as it was kind of intended. Whew. I'm excited. I really am. This has been a couple of years in the making, so I've enjoyed this process. I'm trying to make an open source prosthetic sensor that people can build their own, and this is where it's at right now. I'll show you where it began. So this is where it all began. Just to kind of go from where we started. Here is the first sensor. I was going to put electromagnets, wire my own. I wanted a grid. I was very grandiose, thinking I was going to have a 4x4 grid of these things. I hope to get there someday. Just measuring the magnet passing forward. I actually used in this one the magnets, which they're plastered on the bottom. You can't quite see them there. So this is where it started. Loading all these magnets in the right spot was difficult, but the magnets that went past the electromagnetic wire that I ran, they were on a cushion of air, and just the magnetism itself would be the spring. I then tried to build this, which I just showed you, and that's when I actually had 4 pistons instead of 16, and I had some different boards that I created for that. And then I went all the way from that down to 1. I skipped 2 and just went down to 1. This is the SSD 1306 that was plastered on the side. So I had these cells, and there was 4 cells, and they're all run off of an RP2040 chip, and it has 4 ADCs, but I think only 3 of them are not attached to anything else. So this was attached to this, the cello one. So this is the computer part. You can see it on my arm like this. I had a screen, I have buttons, and I'm pretty sure if I plug this in, it might even say something. I don't know. It is still alive. That's crazy after all this time. So this was the single device with 4 sensors after the 16. So when I simplified it to 1, the cell like this with, 4 other ones, I realized that I needed to actually not only build the next one, but I needed to build a method of storing the data, labeling the data, because I wanted to use supervised machine learning. So what I built next is these hodgepodge of Velcro hand things. I realized that this is not a very straightforward method of solving that problem. So I went and purchased a High Wonder device, and this has potentiometers. So I just tapped into it with an ESP32C3, literally just tapped into the potentiometers and read them with the ADCs on ESP32. And then even that was a little too cumbersome. So then this is just building the last system with one of these, and this one could work, who knows, probably does. It has the same thing where I flipped this thing on the wrong side, and this was meant to be put onto a finger exerciser, kind of like this. I then created this, which was the last 4 system. So this was the one I actually finally got working, and that was made alongside, I'll show you the first prototype first, the Open Muscle 5.3.0. But it ended up being something like this. But these I end up replacing, but the basic wiring is 1 ESP32 wired up to 6 boards with 2 sensors each. So the one that I got working and successfully was able to measure the fingers was this one. It was the 2x6. That one, I believe, is the 1x12, because there's 12 sensors. You can orient them in 2 rings or a single ring. These are literally clevis pins with safety pins behind them. I have lots of diagrams of these, but these were cumbersome to make. Before I went to the foam, I made this system, which was a clevis pin and a magnet. So there's a little spring and a clevis pin with a pin at the top, and the springs in between the plastic. And the reason why these wobble around is because I was trying to reduce friction in the system. And if you have the whole tube, adding friction to it, it doesn't work too well. So then I worked with Ultimate Robotics. So I went from the Lask, which has 4 pistons, to this U-Label, which is an NRF 52832 microcontroller with 5 Hall effect sensors and 5 pistons. And so this thing I designed with the help of Ultimate Robotics. We put everything together, put our brains together to create a label device that is pretty darn robust, if I do say so. But today, we have the new open muscle cell. I think we'll leave off there. Thank you so much for watching. If you like my content, please like or subscribe. Please leave a comment what you think about this project. Are you working on any other projects? Anything that tickles your fancy, please leave it below. If you want to join, either leave a comment or on the website openmuscle.org. You can go to that and there's a contact me section, and I do read the stuff that gets sent there. Just leave off with the same thing. Let's see if we can make a positive difference in this world. Until next time.